let's go back for a minute to the magic hat. What happens if I put a rabbit into the magic hat and I pull out a bag of rice? This would make an inverse function for this. Why? Because it undoes this function. The light blue function undoes the dark blue function. Here, if I were writing this one, let's say I had an input and an output. If you compare this with this, at least up to this point, this is an inverse relation. I put in a 1, I get a 2. I put in a 2, I get a 1. Put in a 3, I get a 4. Put in a 4, I get a 3. You've dealt with inverse relations before. 3 plus 4 equals 7. 7 minus 4 equals 3. That's an inverse relation. 3 times 4 equals 12. 12 divided by 4 equals 3. 2 squared equals 4. Square root of 4 is equal to 2. These are all now inverse relations. Is this a function? An inverse function? Yeah, because for every number I subtract, I'm going to get a unique number over here. Same thing here. Is this a function? Well, it kind of depends on how you define it. There are some books that say that if you don't have a sign in front of this, it's period. It's positive. Okay. On the other hand, if I said this, well, the square root of 4 is actually plus or minus 2. Well, this would still be an inverse relation, but it would no longer be a function. Going back here for a minute. Whenever you have input and output, the input is called the domain. The output is called the range. Okay. For this relation, if I restrict the domain of my inverse relation to these 6 numbers, that makes this a function. If, on the other hand, I do that, we have a problem. Here, I got all the way to here, and this was still a function, even though 19 went with 8, and 7 also went with 8. But if I turn it around and create an inverse relation with all those numbers, the minute I get here, it's still an inverse relation, but it's not a function anymore. What does that look like on a graph? If that's my graph, where these are the x values and these are the y values, in order to make it an inverse relation, I just have to switch the position and go like this, because now all of my y's are related to my x's in exactly the same way. When we started dealing with square roots, we were dealing with quadratics. Is that a function? Yeah. Take a look at what happens. Vertical line test passes with flying colors. There are all of my x values. There are all of my y values. There is no x value that has more than one y value. But if I look at the inverse relation, and I do this, so that now my input is the y and my output are the x's, is that a function? No. So in order to determine whether or not a function has an inverse, if you're looking at a graph anyway, there is something called the horizontal line test. And the horizontal line test will tell you whether a function has an inverse relation that is also a function. In this case, no, because there's a horizontal line with 2 points on the curve. Here, not so much. Never more than 1 point on the curve.